Welcome back to Note Studio. In the last video, we have discussed about thermal decomposition reaction, the reaction which occurs with the help of heat energy where single reactant breaks into form two or more products. Today let us study about the second type of decomposition reaction, that is electrolytic decomposition reaction. It's also known as electrolysis. So it says decomposition reactions which take place when electric current is passed through the compound in the molten state or in the aqueous solution. These are called electrolytic decomposition reaction or electrolysis. What does it mean? So here single reactant, it breaks into two or more product with the help of electric current. So when the electric current is passed through the compound, so what is the conditions here? Compound should be in the molten state or in the aqueous solution. The solid form, it has to be melted, okay, that is molten state, or it has to be the solid compound has to be diluted in water and we have to make it aqueous. So through which when we pass electric current, the single reactant will broken into two or more product. That is called as electrolysis or electrolytic decomposition reaction. Let's study about one example. To understand this decomposition reaction, this activity will help us, activity 1.7 in your textbook. So it says that in the first step, we have to take a plastic mug and drill two holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in figure 1.6. So as shown here, so we need to take a plastic mug and we have to drill two holes here. What is the reason? We have to fix two carbon electrodes, or we can say like graphite rods. So here black color is shown, no? That is carbon rod or graphite rod, it's mentioned here. Next, second step, connect these electrodes to a 6-volt battery as shown here. The two sides has to be connected to the positive as well as negative terminal of the battery. The third one, fill the mug with water such that the electrodes are immersed. So we have to fill water here. That means we can note that water is a reactant here. So here electrolysis of water we are studying. The water will break into two products with the help of electric current. So we have filled the mug with water, and then to this water we need to add few drops of dilute sulfuric acid. See, it says that we need to add sulfuric acid to the water. Acids are good conductors of electricity. The reason is it produces ions in the aqueous in water. So ions can carry the electric current in the water. That's why when we add sulfuric acid, like very few drops, 1 or 2 drops, when we add to the water, the current can pass easily through the water. That's why we are adding sulfuric acid. And the fourth step, take 2 test tubes filled with the water and invert them over the 2 carbon electrodes. So here it is shown 2 test tubes we need to take. It has to be filled with water. Already in the mug we have water and the carbon rod is completely immersed in water. Now again 2 separate test tube we need to take. We need to fill it with water. Then how to keep that? We have to invert. Okay. Say as shown here, the mouth of the test tube is down. Okay. That's why we have to invert them over the 2 carbon electrodes. We have to keep the test tubes reverse. Okay. Invertedly we have to keep it upon the carbon electrode. Now the carbon rod or the graphite rod will be inside the test tube. In that way we have to keep it. Next, the next step, switch on the current and leave the apparatus undisturbed for some time. So next we have to on this battery, when we switch on, we know like this electricity will be passed through this. Before that, we know that there are positive and negative terminal. So here anode is nothing but this is the positive side, and cathode is act as a negative side because we have connected the negative side of the battery, and anode, this rod act as anode because it is connected to the positive terminal of the battery. So when we pass the electricity, as it shown the next step, you will observe the formation of bubbles at both the electrodes. These bubbles displaces water in the test tube. So when we pass the electricity through this water, immediately inside these test tubes we can see the formation of bubbles. Here it is shown, right? In one of the test tube few bubbles are there, and in another test tube also few bubbles are there. So the bubbles will be formed. That shows that this water has splitted. Okay, so water has splitted into H2 and O2 gases. See, when the bubbles are formed, when some gases are present, no, then only the bubbles will be formed in the water. So as it explains, when electricity or electric current is passed through acidified water, acidified means we have added sulfuric acid, drops of sulfuric acid to water, it decomposes to give hydrogen gas and oxygen gas. That's why the bubbles are formed here. Why the bubbles are formed inside the inside the test tube? Because some gases are evolved, and these gases are hydrogen and oxygen gas. Uh, we can represent in this way H2O. Okay, H2O is water, whatever we have taken in the mug. Okay, so when we have passed electric current through this water, we got the formation of bubbles. It's because of hydrogen gas as well as oxygen gas is formed. And two different observations we can see. The first observation is in the test tube covering the cathode, the amount of gas collected is double than that of the gas collected in the test tube covering the anode. This is because the ratio of hydrogen and oxygen elements in water is 2:1 by volume. Have you understood? So here in the cathode side, which is the test tube covering in the cathode side. So this is the cathode side, right? If you observe, the water is displaced more in the cathode side. Before it was full. Okay, before the experiment, we have taken both the test tube. It was completely filled with water. Now we can see after the experiment, or when we have passed the electric current, this side, like cathode side, the test tube covering the cathode side has more space. That means more amount of water is displaced. See, when the gases are formed here, they will go and they will occupy the space here. So to occupy the space, what they will do? The gas will displace the water. The water is coming down, and the amount of water will increase in outside the test tube, that is inside the mug. Okay, so the water will be displaced and gas will occupy the space here. And in the cathode side, the amount of gas is collected more, double than the anode side. More amount of gas is collected because we can see that is hydrogen gas. As when we write the formula of water also, two atoms of hydrogen is present in one molecule of water. Okay, one molecule of water contains two atoms of hydrogen, and when we balance the equation also we can find that two hydrogen, so in two water molecule, okay, produces two hydrogen gas, like two molecules of hydrogen gas, and then one molecule of oxygen gas. So double amount of hydrogen gas is present. That's why here in the experiment also we are getting more amount of hydrogen gas, or double amount of hydrogen gas than that of oxygen. Even here also oxygen gas is formed, and that also displaces, but less amount of oxygen gas is formed. The reason is how much atoms of oxygen is present in water, that much it is produced. Then we have to test this. directly we cannot believe that, right? So what we have to do, so after displacing we have to take this test tube. Then when we do the uh, burning candle test, immediately this will burn with the pop sound. The gas is hydrogen, that's why it burns with the pop sound. When we do the same test here, when we bring the burning candle here, oxygen is a supporter of combustion, that's why uh, that flame it brightens, it burns very brightly. Okay, so these two things we can observe. The same thing is explained in the notes. On testing the gases, uh, the gas in the test tube covering cathode is found to be hydrogen, and in the test tube covering the anode, it is found to be oxygen. So how we can test it? When a burning candle is brought near the mouth of the test tube covering cathode, the gas in it burns rapidly, making a popping sound. Okay, very important, note it as a popping sound because the gas collected is hydrogen and it burns with the popping sound. When we do the same test, when the burning candle is taken near the mouth of the test tube covering anode, the gas in it supports burning, so it's supporter of a burning process. So the candle starts burning brightly because gas collected is oxygen and it supports combustion. So I hope you have understood this activity or this example. So it says about electrolysis of water, electrolytic decomposition we have studied now. So in this type of decomposition, a single reactant, for example, we have taken electrolysis of water. So here single reactant like H2O, it splits into two or more products with the help of electric current or with the help of electricity. So this is about electrolytic decomposition. In the next video, we will study about the third type of decomposition reaction.